Hi everyone. I'm going to go over question number 9.37 from the in-class bingo problems. This question says a uniform sphere with mass 28 kilograms and radius 0.380 meters is rotating at a constant angular velocity about a stationary axis that lies along a diameter of the sphere. If the kinetic energy of the sphere is 236 joules, what is the tangential velocity of a point on the rim of the sphere? So, just to kind of go over a brief overview of what I want to do, is first I want to find the moment of inertia, and I want to do that because then we can use one of our energy equations to find what that constant angular velocity is. And we want to know that because the formula to find the tangential velocity is the radius times the angular velocity. So that's kind of my roadmap. First start with the moment of inertia, then go use energy equations to find the angular velocity, and then use the formula to find the tangential velocity. So start out with our moment of inertia. Since it's a sphere, we know that that is going to be I equals 2/5 mr squared for the sphere. And then we know everything, so we could just plug it in. So that goes to I equals 2/5 times the mass, which is 28 kilograms, times the radius squared. The radius is 0.38. And so now we just plug that in. So we end up getting about 1.6 kilograms times meters squared for that moment of inertia. So we'll write that up here to keep it out of the way. All right, so that's that first step. So now we can use this newly found moment of inertia to, in our energy equation, to find the angular velocity. So we know that the energy is equal to 1/2 times the moment of inertia times the angular velocity squared. And now what we can do is solve for our angular velocity. And so we end up getting, let's see, W squared equals 2E over, I'm going to change the E. I like to use K. 2K over and then we'll square root that. I guess we could also write it as that equals square root of 2 times K over I. So now we have that. We know the values on the other side, so let's plug them in. So the angular velocity equals 2 times kinetic energy, which is 236 joules, over the moment of inertia, which is 1.6 kilograms times meters squared. And so when we solve that, we end up getting about 17.1, or I guess about 17.2 radians per second. So I'll just write that up here. Okay, so now we know our angular velocity, which is important. Now, the last step is really easy, because we know that the tangential velocity of a sphere is just going to be the tangential velocity, which we'll use v, is equal to the radius times the angular velocity. So we plug that in, we get that the tangential velocity is equal to 0.38 meters times 17.2 radians per second, and throw that in the calculator. And we end up getting about 6.5 meters per second for that tangential velocity. So just to summarize what we did, we first of all found the moment of inertia, and then used that moment of inertia in our energy equation to solve for the angular velocity. After we found that, we were able to plug in the radius and the angular velocity into our tangential velocity equation, and we ended up getting 6.5 meters per second. So anyway, hope you enjoyed watching, and I'll see you in the next video. Thanks.